So today's discussion point is constraint application protocol, CoAP. Even our MQTT is also standardized. Okay, here you can see this CoAP is also standardized protocol. Okay, so that now various devices, various deployments, they use this CoAP or its what you can say derivatives or its implementation as per this RFC 725 standard. Okay, so remember CoAP because this comes maybe in the Viva or kind of a constraint application protocol. Okay, and the name when it says that it is a constraint, obviously it implies that this is going to be for low capacity devices. And the common scenario of where you can find these devices is our IoT deployment. Okay, you can say this WSN, but now when we say WSN is not our point of discussion now. Our point of discussion is IoT deployment. Okay, so all this what I can say nature of or characteristic of these devices, they are actually for this IoT. So CoAP, it is for as the name suggests for constrained devices, and it is a straightforward simple protocol with low overhead, and it is for what you can say exchange of data. Other thing, because we have seen this security also exchange of data between devices. Okay, so we exchange something, and we this need for this protocol we have seen because this sensor want to send the data and services want to read the data from the sensors, and these sensors as we have seen they are constrained devices. Okay, so in this IoT, and we have started with this machine communication, then machine to machine communication, then IoT and IoE. So at very base level, when even if we are having this IoE deployment, there is a machine to machine data exchange. And even in here you can see that this line here it says that no machine to machine data exchange is done using HTTP also. Okay, so but HTTP in the previous, as I just started with this sentence that HTTP needs high resources, whereas CoAP is designed for low resources. Okay, so it is web protocol designed for constrained devices, and it is implemented for machine to machine communication. For example, even if like HTTP is doing what your browser is there, Chrome browser can be seen, and it is actually communicating with IIS server of certain website, and then there is a data exchange between Chrome and website. So this is a machine. We here can see this is client and this is server. So server and client, they are communicating. Essentially, they are communicating. Essentially, it is actually machine-to-machine communication, and they are talking with the HTTP protocol standard. Okay. Now, same thing when we say our sensor device. I'm having here now, for example, Node MCU, and then at other end, suppose I am having this Raspberry Pi as gateway device. So these two devices they are want to communicate. But now here main thing is that both these devices are having almost very much constrained capacity. Maybe portable power supply, RAM, ROM, all things are very less as compared to an entry level laptop. Even entry level laptop, it is much powerful as compared to these devices. So it is a web protocol, and obviously when I say I Internet of Things, it is web protocol and constrained devices for our IoT deployment. Asynchronous message exchange, like even HTTP is also asynchronous message exchange. So it is not like that. No, there has to be both the devices has to be communicating or has to be online. It will go for HTTP along with TCP/IP. They will go for best effort delivery. They will go for best effort delivery, but still HTTP is what you can say their request and things are there, but asynchronous. It will post the request, it will wait for reply, and then the reply will come, and accordingly it will exchange the things. So asynchronous message delivery is there in case of CoAP also. And why I am what you can say referring HTTP, I will just discuss at the end of what you can say this slide discussion. And universal resource in the identifier and content type support is there, and proxy and caching capacity. So this will help uh, the devices for compatibility with REST APIs. Okay, because it's these REST APIs, they are actually located using HTTP endpoints, and these HTTP endpoints can be consumed using this CoAP at your device end. So your devices can invoke REST what you can say RESTful services, and yeah, you can do lots of things. Proxy and caching capacities, all these things are regular. So these are the key features. Now, why we are comparing this feature with HTTP? Because many times this you will refer this CoAP as, no, I will say that uh, a simple version of HTTP. CoAP protocol, it is a simple version. It is a simple version of HTTP. Okay. So what HTTP can do, CoAP does for small devices, not everything, but or rather other way around, I'll say that what CoAP can do, everything is possible by HTTP. Other way around. Remember this thing. But CoAP is lightweight. Very important part of CoAP is that it is lightweight. Remember this one. Okay. It is a lightweight protocol. Okay. So limited processing memory. We have seen this thing, IoT Ecosystem, everything. Here we have discussed. So let us move ahead for our next slide. Yeah. So yes, these features are very much similar to we have seen HTTP. We have discussed this thing, and for machine-to-machine communication, and that's why it is optimized for tasks. It is optimized for IoT deployments. Okay, so in its what you can say, it is a simplification when you say that CoAP, a HTTP protocol running on UDP. Okay, so because of these things, it what you can say consumption of bandwidth is saved. Why bandwidth consumption is very much required for our IoT devices is that consumption of bandwidth will in essentially will be what you can say resulting in overall saving of the messages and energy which is required to transmit the messages, and it will save help us to reduce the power consumption and increase the battery life and reduce the power consumption. Okay, so saving of bandwidth is very much, we have seen this thing, it is an essential requirement for this concerned devices. Okay, and so that's why this is another important thing. It is essentially the CoAP is underlying, it is using universal datagram protocol UDP, and it is uh, that's why even HTTP is best effort delivery is using UDP. CoAP is using also using uh, CoAP is using UDP for data exchange or data transfer from one point to other point, or essentially nodes on the internet, and that is one aspect of CoAP. Other thing is that our mobile communication network, that is no GSM network, then 3G, 4G network. So they are having something called as SMSC. Okay, so short message service, and S is for center. So SMSC is there in your mobile phone. Every mobile phone has got this SMS number, and using this SMS, okay, to mobile phone, they actually exchange certain message. Okay, so this CoAP, this mechanism which CoAP is followed, that is used widely in SMS delivery and communication. Okay, that message. So remember this thing, CoAP is used here also for your reference and understanding. Okay, so when to use our CoAP? So your hardware is concerned and it cannot run HTTP, hypertext transfer protocol, or transport layer security mechanisms. It cannot run. So that's why here we go for the HTTP. Okay, so yes, so you receive this what you are having get for reading and post and put for delete, all these mutation are there for this HTTP commands. Then you are having portable power source, and a subscription is necessary. So what this subscription is necessary is a what you can say aspect when you are having this IoT deployment. So we have seen this thing previously that sensors are there. So we are having suppose 5 sensors at this one premises. Sorry. So 5 sensors are there, and these sensors they are publishing their data to what you can say gateway device, rather than Bokra you say, and I want to read this data. So either you will have to one-to-one communicate and by the identifier to the sensor, or read the packet at the gateway. Kind of this can be simple, but when your deployment becomes large, it becomes a problem, and then you need to understand that what kind of, and as and when update is there, you will have to read So kind of you are subscribing to this sensor 1 to sensor 5, and that will it is something like this, no, WhatsApp chat. Suppose for example, whenever you are no having some context stored in your mobile phone, and what happens that when you actually your mobile phone, it is having what you can say, there is a something called as message queue, and message queue is always no probed by your mobile phone, and you put your message queue to the what you can say, you put your message to the message queue, and your WhatsApp server sends the message which are coming from other users to the message queue, and then you keep on your, it is like you are subscribing to the message queue or subscribing to the other people, so accordingly you will get maybe the status updates are there. So if the contacts are saved on your mobile phone, you are subscribed to their status update, and then accordingly as and when the person updates the status, you will get that okay, this person has got the status update. So it is kind of the subscription mechanism. Okay, you don't have to technically go to that person's contact and then see the status. No, in your status page, that status page of your WhatsApp, you will see the green dots are there. So wherever your subscription means, you have saved the contact, and whenever you are saving the contact and these contacts are there, you will say okay, yeah, this person has got the status update kind of thing. So that update, so this as and when person updates the status, it will send update to all the people who's actually whose phone has your number saved in their address book, your WhatsApp address book, and then that status will be delivered to all the people. So this is a subscription kind of this is very means that is our day-to-day life experience, and that's why in such case like same thing happens when sensor data is to be read. So we are subscribing, we want to read this 5 sensors data, so I'll say that that kind of mechanism, then CoAP has to be used. So and essentially CoAP is one-to-one protocol, but it is handling that no update kind of mechanism. So here you can see that this your sensor, okay. So it data is converted, and then you are having this CoAP protocol, which is actually getting the data from the sensor, and then IP version 6 or IP version 4 4 is there, and you are this here it can be seen mode running open WSN. Here we are having our node MCU or no simple IoE node is there. Hmm? And then using this IP version 6, we are communicating with the internet, and then your client here you can see, and your IoT service. So this data will be pushed to the IoT service first, so like Amazon IoT core service is there, and or kind of no Azure IoT core service, and you are having your mobile application maybe, for example Blink, I will say that, and here you are having Blink server. So similarly, this data comes, it goes on Blink server, your mobile phone or your application, your Blink application communicates, and data is fetched here. CoAP request is made for your sensor, and you get the plot of your temperature increase or decrease on your mobile phone. So technically, your client is never contacting the sensor directly; rather, it will contact it to the Blink server on which the subscription is made. Okay, so this is another deployment example where you are having this RESTful APIs are there, and here you can see that this layers are there. Okay, in case of normal what you can say device like your laptop or the server, and here is your IoT node is there. So you are having payload, TCP, IP, and Ethernet link. So like I'm talking to you on this laptop. So these are the what you can say headers, or this protocol stack is there, you can say. And in case of your IoT consent nodes, you are having payload means your sensor data, then your CoAP packet header, UDP packet header, and IP. So whatever the job is done by TCP here is done by UDP, Universal Datagram Protocol, and on the consent link, so 802.11 BGN, whatever, it will transmit this data. So here, that's why here you can see that no, this device is in the typical IoT deployment, server, no, this node to node, actually HTTP endpoints are there. They are communicating on server to server, maybe HTTP communication is possible, and then even this server can directly be subscribing to this client or through other what you can say proxies. They can even actually see it as already the server, proxy HTTP is there, and HTTP and CoAP proxy and client is your sensors. They are having this CoAP protocol communication. So CoAP actually for low constraint device, everyone is talking with CoAP. For this high configuration device, they may talk with HTTP or they may talk with CoAP. So both things are possible there. Hmm. So another thing. So another now this new protocol comes here. For protocol other than protocol, I will say that here abbreviation that is no IP version 6 low power low power low power wireless personal area network protocol. So WPAN, here you can say WPAN wireless personal area network, and IP version 6 here low power. So typically this is read as 6 LO WPAN, but when we interpret this thing, we interpret this thing as IP version 6 low power personal area wireless personal area network. Okay, so remember this thing maybe for Viva or for interview questions. This is very important. They may ask you what is 6 LOWPAN. So that can be accordingly, that should be accordingly answered. So yes, application layer protocol, you can say CoAP, transport layer protocol, you can say here UDP, which carries the data. Then network layer for IP communication is there, and then link layer you are having SMAC protocol in case of your sensor MAC wireless device, constant device. They use SMAC protocol here for your web servers. Okay, when this what you can say like our laptop or desktop machines are there, so they are having this protocol stack XML that for the data exchange, and HTML HTTP is there, transport TLS. Then for encryption purpose, then TCP and IP they will carry the data. So this is actually formatting kind of data, formatting and security. Here for IoT, you are having web object, then CoAP, DTLS, UDP, and IP version 6 low power wireless personal area network. So datagram transfer layer security for this low power device constrained devices. This is CoAP protocol stack, and this is for your normal HTTP protocol and stack. So questions may come on this thing. What is the protocol stack? And here that's why accordingly, here what are these layers, then protocol stack, and what happens on the functional plane can be seen. So application layer protocol, MQTT, HTTP, QAP, transport layer protocol, UDP, and TCP. So we have seen this for web servers. They use TCP. For constant device, they use UDP. Network layer, it is using internet protocol only, IP. So UDP IP or TCP IP in case of our sensors and these modes, they use CoAP, UDP, and IP. For our machines, high config machine, they use TCP IP protocol. And at the physical link layer, as now it is wireless network, so we have seen that 6 IP version 6 low power wireless personal area network, and they will be using 802.11 BGN or 802.15.4 wireless communication standard. Okay, so here the typical these packets are there. Your web application packet, then your IoT backhaul, it is reduced to no web objects, UAP, DTLS, and UDP. And router for routing at your IoT network, this is having IP version 6, and then this protocol stack. So at what you can say web application protocol stack, your IoT backup protocol stack, and these are just the variants variations when we have different type of devices on our IoT or internet networks. So how this data is exchanged at different type of machines can be seen here. So here you can see for our web browser HTTP is there. For your IoT network, then you are having this wireless this proxy and then CoAP message, and they are actually what you can say connected communicated to the server through the UDP sockets are there, HTML5 web sockets are there, and communication or data is exchanged. So typical lightweight machine-to-machine network can be seen here, exchanging data. So front end, your mobile phone and client side, they are seen here. Cloud services can be seen. Then app services and gateways. Now, when we look at the bird's eye view at your network, and these things you can can be seen. So and then here you can see lightweight machine to machine client. Okay, CoAP nodes are there having various types, various functionalities are there. So typical smart city slash home applications. Okay, and now this is full ecosystem, you can say that, and they are communicating. So simply, so that's why from no simple machine to machine communication to now we are coming to IoT ecosystem. Okay, lightweight IoT machine to machine network. And beyond that, when cloud and front end and analytics part come, people process data storage and discovery, it becomes IoE network. Okay, so levels of experience, there it is going on increasing. So just a minute. Yeah. So the question comes in your university exam as inquiry and COAP, their comparison, similar points and distinctive points. So let us see what are similarities. So both message queuing telemetry transport and constraint application protocol, both of them are open standards protocol. So maybe you can discover the source code of that thing, and maybe you can modify that MQTT COAP as per your machine and application needs. Okay, and obviously they are better suited for WSN slash IoT slash IoE deployment concerned devices for asynchronous communication. So that is very important because it may happen that depending on network condition, all sensors may not be responding at a given point of time. But as and when the network connectivity is coming, they may connect to the what you can say your gateway device and transfer the data. And both MQTT and COAP they run on IP. We have seen that COAP, UDP, IP, MQTT, UDP, IP, and we have seen this HTTP, TCP, IP. So this communication stack is there and have a range of implementations. Obviously, depending on your application and overall requirement, you can choose for COAP or you can choose for M. So if you are having less number of devices, you can go for COAP. If you are having thousands of devices and machine to means many to many type of communication you want, then you can go for MQTT. So like of this thing. So large scale deployment, MQTT is a better option. Okay, so here you can see or both means MQTT and COAP both. So this is a what you can say typical scenario. So here you can see now your this mobile phone is having HTTP, TCP, UDP, IP communication. Then you are having your MQTT devices which are having MQTT, TCP, IP version 4.6, and your MQTT node is communicating. Then COAP node, so IP, UDP, COAP communication, and they are exchanging the data. Then you are having various sensors. So here you can see sensors are communicating in between, exchanging data in between them. So they are using COP because COP is point to point as communication. It is allowing, and MQTT is having publish subscribe model. So these sensors they are actually exchanging data between your MQTT broker and the sensor. The data exchange is happening depending on the publish and subscribe status. And then this cloud services backend, that is our backhaul services, they are communicating either directly through the sensor through COAP or communicating to the broker for the getting data through the subscription. Okay, and without COAP gateway also some devices can talk to cloud. So that is a typical deployment or what you can say a complex application. These are the possible implementation scenarios when you are having this IoE deployments are there. So this is for understanding purpose. Yeah. So another thing, yeah, the MQTT deployment through broker only this thing goes, but COAP, yeah. So these devices can directly there can be multiple servers. Then this client and server they can exchange the data between them using point to point communications. Okay. So yes, this comparison, sensitive application protocol, message queue, telemetry transport. It is request response model, okay, as well as public subscribe model both. It is using purely public subscribe model. Okay, restful, yes, restful, no. So it is having support for restful communication. This is very important because then in using restful endpoints we can consume web services. So that is very important. And when you what you can say using, for example, using simple node MCU, and if you are having no an application to want send an SMS, so you can use RESTful APIs of SMS server and send message directly using this. You don't need any web service or kind of thing. Simply RESTful API service is available to you. You can use CoAP, what you can say, uh, CoAP packet, and you can call that HTTP client because it supports RESTful APIs. Representational state transport that communication. The RESTful API support is there for CoAP. For MQTT, it is not there. Header size 4 byte. Here MQTT header size is 2 byte. So MQTT is lightweight as compared to CoAP. Number of message type 4, number of message type 16, more number of message size either for configuration purpose, communication purpose, state communication purpose. A number of things can be possible using this message types. Asynchronous, synchronous, both communications are allowed in MQTT, CoAP. MQTT is asynchronous. Application reliability, there are two level, three level reliability there. Security is using your datacom transport layer security or IPsec protocol. It is not defined in standard, but you can use your own implementations. Yes, intermediaries possible. Yes, here intermediary possible. It allows MQTT brokers. Okay, here you can use servers or gateway device as intermediary. So LLM support, thousands with large level networks are there. Yes, CoAP supports, and your MQTT is also having fair support. And obviously, it is application wise. We are actually having the IoE deployment, so both of them are very much suitable for IoE deployment depending on your functional requirement. Okay. So both useful as we just discussed, both useful as IoT protocols and have some fundamental differences that we have just seen. Okay, many-to-many communication protocol for passing message between multiple clients through central broker, and it decouples producer and consumer by letting client publish and having the broker decide where to route and copy message. This is very important. Okay, so it also support persistence, but better the persistence or the live data means what happens with persistence. 1 hour back, some message is there. Can it be? Will it be available right now? May not, depending on the how much buffer and the storage you are allowing. That is the idea. Okay, but CoIP is primarily one-to-one protocol for transferring state information between client and server, and it supports observing resources like publishing separate model and for trace state transfer model. Okay, so not purely event based. It is having. Okay. So MQTT client make long-live outgoing TCP connection to a broker, and this is generally for when you are having, for example, so you are having a college network, then gateway, and then cloud network. So actually for gateway, there is network address translation. This NAT level is there, and then it is communicating on the internet. Okay, so tunneling is used, port forwarding is used. Okay, for what you can say communication to happen. Okay, so that is another important thing because when you are in large scale IoT deployment, so gateway devices will be there and we need to implement that thing, tunneling, port forwarding, address translation, a number of things will happen. So both protocols allow that. Hmm. So here we complete. So here we complete our CoAP protocol. Thank you.